Let's get all the basics of how to sketch a function in Physics 101, and specifically by using the knowledge that we now have of obtaining stationary points and classifying them. What things are important then? First of all, drawing axes is quite a good start. This will tell people, readers, where your variables are growing, and typically you can label them as x and y. If you're looking at a problem in physics, typically you'd put the units here. This is very good practice so people understand what your values actually mean. Focusing on this specific function, one of the first things you should probably have a look at is what is the value of the function when x equals 0. Essentially what y you get when you plug in x equals 0. In this case, we see that the value would be 0, so you could start by sketching it even from here. The next thing you could do specifically on this function, we know that there are only two stationary points. They exist at x equals -1. Therefore, labeling -1 and +1 is a very good idea. In this case, we know that x equals -1 is a local max, and that x equals 1 corresponds to a local minimum. Typically, the other thing, therefore, that you want to calculate are the values in y for the stationary points, which means we should calculate what is the value of f when x equals -1. In this case, you get -1 plus 3, that's 2. You can label 1 and 2. Let's say -1, -2. And it means at this point, the function is defined there. And this will be a local max. So we know that the function is probably going to be doing something like this. On the other hand, for the other stationary point, that's x equals +1, we get 1 minus 3, that's -2, and the function is here, which means it crosses y equals -2 for x equals 1. We also know that this is a local minimum. Therefore, the function must be doing something like this. This is a local minimum, local maximum. There are no other stationary points, and the other thing we can calculate is the limit when x goes to +∞ of our function, which is +∞. This is where it's going. And for -∞, we can write that the limit when x goes to -∞ of f of x is -∞. This is where the function is going to. Therefore, we've essentially included all the important aspects to visualize function f of x. We've showed where it crosses x equals 0. We've labeled and indicated the stationary points, and we very roughly connected them given the information that we have without using any software or calculators. And specifically, if you're dealing with a problem in physics, it is very important to label the units. In addition, if your variable is, say, mass or time that can only be positive, when sketching a function, you probably want to restrict yourself to this part because you're showing your understanding of the problem. Mathematically, you may have a behavior for negative values, but if you're describing mass, you definitely should be focusing on the positive values. The great thing about sketching things properly and following good practice, such as things that I've tried to point out and that you also find in the lecture notes, is that people very easily understand the function you're describing. They'll be able to easily grasp the information they need, and typically they'll be able to reproduce what you did as well. In the lecture notes, you may find this plot over here. It's an incredibly famous plot made by someone who's equally famous. I mean, he even has a space telescope named after him. That's Edwin Hubble. If he was a student at Lancaster doing our labs and submitting that plot, he would probably have failed. And Hopefully, if you paid any attention and if you read the lecture notes, you can identify the many mistakes or bad practice examples that are contained within this plot. One of them is that on the y-axis, Hubble labeled velocity in terms of distance. That's really bad. So instead of kilometers per second, he actually wrote kilometers. An even bigger problem is that those measurements of Doppler velocities or shifts that we can measure for distant galaxies were measured by someone else, but Hubble just included them without error bars, without citing the other astronomer, and even getting the units wrong. That's pretty bad. Other examples of bad practice or bad scientific practice is not including error bars, which in a lab would probably cost you quite a few marks. And in addition to all that, and even though this is an incredibly transformational plot, this is the moment when we realize that the universe was not static, it was expanding. This was a huge breakthrough. Yet, even the distances, the things that Hubble actually measured, were wrong by a factor of something like 8 to 10. So plots can be very famous, they can be very wrong, but hopefully when you do get a telescope named after you, you will look back and see that your plots are all perfect because you've actually paid attention to Physics 101. And by the way, this is also going to be incredibly relevant for the worksheet. Especially, don't forget about units and whether a physical parameter can be negative. And if not, do not plot it.